Okay, fine. I want to change the directions in this assignment. It says you're finding all roots in the equation. No. You're going to find all but the last two, okay? Well, this is going to be simple because it has 3 roots. You don't have to find the last 2. You just have to find all of them but the last 2 today, okay? It's to set us up for tomorrow. Now again, I'm going to explain why grouping is not going to work here, even though there's 4 terms. Just watch this, okay? If I try to factor that expression, okay, and set up the grouping, put those 2 and those 2. The GCF's 1x squared here, it's negative 1 here. Problem is they don't end up the same, so that's a prime. So that's why we need to kind of know some of these tricks here. Now yesterday I gave you the first one and you found the last 2. Now today I'm going to change it opposite. You're not going to find the last 2. I don't care about that today. Okay? I just want you to find all but the last 2. Alright, so you have to apply something that's new. It's known as the rational roots theorem. Okay? This is how to apply the rational roots theorem. I call it RRT. You make a big division line. Now in front of the top, you put your constant, 22. It's got to be done like this. On the bottom, you put your leading coefficient, which would be 1. Now find all your factors of 22. Well, 22 divided by 1 is 22. 22 divided by 2 is 11, so I put 2, the number you divide by, and then the partner that you get. 22 divided by 3 is a decimal. 4 is a decimal. 5 is a decimal. 6 decimal. 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 Now I'm not going to do 11. I'm done. I don't go to 11 because I already have that. Okay, as soon as I get to a factor I've already had, then I'm done. That's all the factors. Then 1 is 1. Now divide all of these by 1. Not hard. It's just going to be 1, 22, 2, and 11. Now the thing is, these could be positive or negative. Okay. Then, remember, you don't have to find these last 2. Just block those out. So I just need you to find the first one. All but the last 2, so which should just be 1. Now, these are your options. You put them into a calculator and you want to get equals 0. So 1 parentheses 1, one's always going to be a possibility. These are your possibilities. Now we've narrowed it down. I just directly substitute those into the equation for every x. Okay, so I didn't get 0, so it can't be 1. Now, try 2. Nope. Okay. 2 doesn't work either. Now try 11. You have to reset your calculator into position. Okay. No, that if it's getting just insanely high, 22 is not going to be it either. Okay. Now put in these integers as negatives. So 1 parentheses negative 1 to the third. Minus 4, negative 1 second, minus 1, negative 1, plus 22. Okay, I got 18, negative 1. Now let's make it negative 2. Basically, this assignment, if you know how to plug it into a calculator, you'll be good. Okay. Bam, got my 0. So negative 2. I don't need to find the last 2. You have to find all but the last 2, which consisted of 1 here. Okay, next one, there's 3 roots. I do not need you to find the last 2 today. We did that yesterday. Okay, we'll do it all together the next day in the next lesson, but not here. Okay, so to find that first one, I apply the RRT, rational roots theorem. So you take your constant, 2. It's negative 2. You just need to put 2, because we put plus negatives on them anyway, so it doesn't matter. And then 1. Well, this is a short list. 1 and 2. That's all the factors of 2. Then 1 is just 1. So 1 divided by 1 is 1. 2 divided by 1 is 2. Plus minus, plus minus. Okay, now plug them in. Start with the positives. Now that last one I had to go a little while. Second power. That third power is caret 3. Okay, that's how you do that. Minus 4, and then 1, minus 2. Oh, bam. Didn't take long. Okay. Moving on. Next page was blank. Sorry about that. Now, we're doing the same thing, but it's different terms. Finding the zeros of the function means you just set the dependent variable equal to 0, and then what I like to do is just put equals 0 there. That's how you find the zeros of a function. You just set that dependent variable equal to 0, and you're finding the values for x that can make that 0. I do not need you to find all of them. All but the last two, just don't find those today. So all we have is 1 to find. We find it with the rational roots theorem. Okay? So you take your constant at the end of the problem, and your leading coefficient's 1. 9, 1. Factors in 9. 9 divided by 1 is 9. 9 does not divide by 2. 9 divided by 3 is 3. Now, if you get double factors like that, you're done. Okay? That's all the factors that exist. Whenever you get doubles, you cross one of them out and you're done. That's the end of the list. You can't have any more when you go in that order with that frame of thought. Okay? So 1. So 1 divided by 1 is 1. 9 divided by 9 is 9. 3 divided by 1 is 3. And those are your possibilities. See, I don't want to just plug in stuff that doesn't have any chance of reaching 0. So 1 parentheses 1 to the third minus, you can slap a 1 there, or you can just plug in the parentheses, 1 to the second, minus 3 parentheses 1, minus 9. Didn't get it, now go to 3. 2 is not on the list, so I don't even want to waste time with 2. There, 3. Okay. Don't need to find the last 2. Okay, 0 is a function. Remember, f of x is like a y. So our independent variable, then 0, then just transfer the equals 0 after. I don't like 0 equals, I like equals 0 better. So there'd be 3 roots because of the third power. You do not need to find the last 2, okay, today. You'll have to find all of them in the assignment tomorrow, but we're just teaching you how to apply rational roots theorem today. Okay, 5 is the constant at the end. 2 is the leading coefficient. Now, it's a little bit different. So 5, the only factor 5 divided by 1 is 5. 5 is not divisible by 2, or 3, or 4. Then I'm just at 5 again. Well, I already have that. As soon as I run into a factor I've already have, then I know I've reached the end of the factors. 2 is 1 and 2. Now, you have 2 numbers underneath here now. So you need to divide 1 by 1, that's 1. 5 by 1 is 5. Now you have to take the 1 and the 5 divided by 2. 1 divided by 2 is a decimal, so you can just put up 1/2, okay? Then 5 divided by 2 is decimal, just put 5 over 2, okay? Now, plug 1 in, let's do 1 and 5. Let's do the fractions after if we can't get it to 0. So 2 parentheses 1 to the third minus parentheses 1 to the second plus 2 parentheses 1 plus 5. No, now let's go to 5. Okay. No. Now, let's do the fractions last. Let's see if the negative of the integers work. Okay. Fractions will be the last thing we go to. Okay, see, -1. I don't need the other ones. Okay, then our last problem here today, kind of a short assignment. Remember, f of x means it's just in functional notation. That's the same as y. Finding the zeros is just whatever you set that, the dependent variable equal to 0. Now x is to the 4th, so there's 4 roots. Now remember what I told you. You're finding all but the last 2. So now you need to find 2 with the rational roots theorem. okay? So if you get 1, great, but you need to follow directions. I want you to find all of them but the last 2, but now there's 4, so we have to get 2 with our RRT. So the constant's 18, the leading, by the way, you put 18 up there, that's easy to see. Don't put 4, you don't put the exponent, you put the leading coefficient, 1, okay? Factors of 18, 1 and 18, 2 is a factor because 18 divided by 2 is 9. 18 divided by 3 is 6. 18 divided by 4 is a decimal. 18 divided by 5 is a decimal. And then I don't need to do, I can stop there because I've already got 6, okay? So that completes the list of factors. You know it's completed when you divide by something you already have written down. And 1 is 1. Okay, divide by 1, simple. That's 1, 18, 2, 9, 3, 6. There's not another number there like there was on the last problem, so that's the list I'm going with. Remember, we got to find 2 using the rational roots theorem. Okay, so I've got 1 to the 4th, plus parentheses 1 to the 3rd, minus 7 parentheses 1 to the 2nd, minus 9 parentheses 1, minus 18. Nope. Now, 2's on the list, just swap out the 1's for 2's. Love these calculators. Nope. Swap out the 2 for 3. Now, if you feel that it's just becoming more and more extreme, then you'll switch to the negatives. Okay, 3, nice, okay. Okay, now I got to find another one, so let's make it 6, okay. If you get something like that, that's crazy extreme, you might as well just switch it to the negatives, okay? Because all that's doing is just getting crazy high. I mean, like stuff in the thousands, okay? Or the hundreds or the thousands. When you start getting into the hundreds and the thousands, start making them negatives. So 1. One didn't work, negative 1 didn't work, now swap it out for a negative 2. Okay, negative 2, that's not extreme. Extremes be like in the hundreds and thousands, okay? Now swap it out with 3. Because 3's on the list. 4 is not, so if this 3 doesn't work, I obviously don't go to 4. That's not a possibility. Okay. Donezo.